September is one of those transition months in the night sky. Early on September evenings, with the summer Milky Way still there, you can feel the sky starting to change. The nights are getting a little longer, darkness is coming a little earlier, and the autumn constellations are beginning to appear in the east. September gives us a lot to work with. The planets are putting on a great show. There's an exciting story in space news, and we'll spend some time with both the moon and the deep sky. I'm Wayne Zool, and this is the AstroGuy podcast. Just a gentle reminder that you can download the current observing guide for the episode at astroguypod.com. You'll also find previous guides there, along with episode notes and more. The guide has a moon phase calendar, planetary data, deep sky notes, and a few extras to help you plan your observing for the month. So, when you're ready to plan your September nights, that's the place to start. But for now, let's head outside, look up, and see what's up in the September 2026 skies. Let's begin with our Planetary Roundup. Mercury is going to be tough to pick out this month. It stays low in the twilight, so unless you have a really clear western horizon, it probably won't be an easy target. There's a very thin crescent moon about 10 degrees to the left of Mercury on September 12th, and that may help you find the area, but this will be a challenge to spot. If you do try for it, make sure the sun is completely below the horizon before sweeping anywhere near that part of the sky. Venus, on the other hand, is easy. Look low in the western sky after sunset, and you really can't miss it. Venus reaches its greatest brightness of magnitude minus 4.8 on September 22nd, so this is a great month to point it out to people. It's bright enough that someone who doesn't normally pay attention to the sky may notice it, and that gives you a perfect chance to explain that they're not looking at a star, they're looking at another planet. And on September 14th, the moon joins Venus in the evening sky, appearing about 5 degrees to the left and slightly above Venus. That should be a beautiful pairing. If you have a clear view to the west, this is one of those nights where even a phone camera can capture a beautiful scene. Mars is in the morning sky this month. It's not at its best right now, and through a telescope, it's going to look pretty small, but it's still worth keeping track of. On September 6th, the moon passes about 6 degrees above Mars in the eastern sky. Jupiter is also in the morning sky, and it is always worth a look. Even when it's not at opposition, Jupiter is one of the best planets for a small telescope. The cloud belts can show up in modest equipment, and the 4 Galilean moons are always changing position from night to night. Sometimes one moon is off by itself, sometimes they're lined up on both sides, and sometimes one of them disappears in front or behind the planet. As the year goes on, Jupiter will improve and rise earlier as it heads towards opposition. The moon passes near Jupiter on September 8th, so if you're up before sunrise, look for the moon first, then look below the moon for bright Jupiter. Saturn is coming back into prime time. Its opposition is in early October, so consider this month a warm-up. By later in the month, Saturn is rising earlier and becoming a much better evening target. Now the rings are not wide open like they were several years ago. They're much narrower right now, as we've discussed previously. As an observer, it can be fun to watch Saturn's ring tilt change from year to year. Even with the ring still narrow, Saturn still looks amazing in a telescope. The moon passes near Saturn on September 27th, just after full moon. The bright moon will make deep sky objects harder to see, but most of the planets are bright enough to handle the moonlight just fine. Uranus is up in the morning sky and continues to improve as we get deeper into the fall. Even though it's technically bright enough, Uranus is not something most of us are going to pick out with the naked eye. But with binoculars or a small telescope and a good chart, you can track it down as a tiny pale dot. And then we get to Neptune. Neptune reaches opposition on September 25th in the US. Opposition means Earth is passing between the Sun and Neptune, so Neptune is opposite the Sun in our sky. It rises around sunset, stays up all night, and it's at its brightest for the year. But in this case, brightness is relative. Neptune is faint. It's around magnitude 7.8, so you're going to need binoculars or a telescope, and you're definitely going to need a good finder chart. In most backyard telescopes, Neptune looks like a tiny bluish point, and under good conditions with enough magnification, maybe you can make out its tiny disk. But that's why finding it can be fun. When you find Neptune, you're looking at the most distant major planet in the solar system. You're seeing a world almost 30 times farther from the Sun than the Earth. Of course, I'll have the moon phase calendar, planetary data, and observing notes in the September guide at astroguypod.com. For space news this month, we actually have a pretty big story. NASA's Nancy Grace Roman Space Telescope is currently scheduled to launch no earlier than August 30th aboard a SpaceX Falcon Heavy rocket from Kennedy Space Center in Florida. Roman is NASA's next major space telescope, and it's designed to do something very different from Hubble or the James Webb Space Telescope. Hubble and Webb are incredible at looking deep into small areas of the sky. Roman is designed to look at large areas of the sky very quickly in infrared light. According to NASA, Roman will have a field of view about 100 times larger than Hubble's, which means it can survey huge sections of the universe in a way that Hubble was simply not designed to do. That wide field view is going to help astronomers study dark energy, map the large-scale structure of the universe, search for exoplanets, and find things that change over time, like supernovae and other transient events. The telescope is named for Nancy Grace Roman, NASA's first chief astronomer, who played a major role in making space-based astronomy a reality. She's often called the mother of Hubble for her early efforts in making the Hubble Space Telescope a reality. So it's fitting that this next great survey telescope carries her name. If the launch goes as planned, Roman will head to the Sun-Earth L2 point, about 1 million miles from Earth, the same general region of space where Webb operates. And this is one of those missions that could change astronomy in a big way, because it's going to collect enormous amounts of data across huge areas of the sky. To put it into perspective, once Roman is fully operational, it's expected to collect about 500 terabytes of data a year. Hubble has collected roughly that much over more than 3 decades in operation, so Roman won't just look deeply into the universe. It's going to look widely, and that wide view may help astronomers find things they would never have known to look for, one object at a time. So keep an eye on this one. By the time we get into September, the Nancy Grace Roman Space Telescope may be on its way to its post at L2.
Now it's time for the Lunar Feature of the Month.
This month we're actually featuring 3 craters: Ptolemaeus, Alphonsus, and Arzakel. These are 3 large craters centered on the moon's near side, and they make a beautiful north to south chain in the lunar highlands. They're easy to find, they're interesting to compare, and they're a great target for any telescope. The best time to look for them is around first quarter, when the terminator is nearby. That low sun angle helps bring out the shadows along the crater walls, and makes the whole area stand out much better than it does under a high sun. Look for 3 large craters stacked almost in a line. The northernmost crater is Ptolemaeus, named for Claudius Ptolemy, the Greek astronomer, mathematician, and geographer from the 2nd century. Ptolemy's model of the universe put Earth at the center, which we now know is wrong, but his work shaped astronomy for well over 1,000 years. So even though his cosmology did not survive, his influence on astronomy did. Ptolemaeus is the largest of the 3, and it has a very different look from the others. It's broad, old, and worn down, with a floor that looks much smoother than a sharp young crater. Under the right lighting, you may spot small craterlets on its floor. Just south of Ptolemaeus is Alphonsus. Alphonsus is named for King Alfonso, the 10th of Castile, also known as Alfonso the Wise. He lived in the 1200s and supported important astronomical work, including the famous Alphonsine tables, which were used to predict the positions of the sun, moon, and planets. Alphonsus is a great crater to spend a little time on. It has a central peak, a more complex floor, and under good conditions, you may notice darker patches on the crater's floor. These dark areas are volcanic deposits, which tells us this crater is not just another impact scar. And then, just to the south of it, is Arzakel. Arzakel is named for Al-Zakarle, an Andalusian astronomer and mathematician who lived in the 11th century. Arzakel is the sharpest looking of the three. It has a more defined rim, a prominent central peak, and a floor that looks much more dramatic when the lighting is right. If Ptolemaeus looks old and softened, Arzakel looks more crisp and rugged. So around first quarter this month, spend some time with this trio. Compare the crater floors, the rims, the shadows, and the differences between them. It's a simple target to find, but there's a lot there if you take your time. After that, we'll move from the moon out into deep space. For this month's Deep Sky Tour, we're staying in Aquarius. Aquarius isn't an obvious constellation from suburban skies. It's large, spread out, and its stars aren't very bright. But if you take your time with it, Aquarius has a nice mix of objects to enjoy. We'll move through the constellation in order of right ascension, starting in the western part of Aquarius and working our way east. So we're looking at objects that set the earliest first. The first object on our tour is the globular cluster M72. At magnitude 9.3, M72 is one of the fainter globular clusters in the Messier catalog. It's not exactly a showpiece, and from suburban skies, it can be a little tough. In my 70mm refractor, M72 looks like a dim, round glow that brightens slightly toward the center. Larger apertures make this one more appealing. In my 8-inch Dob, it's visible, but still not what I'd call spectacular. But in my 8-inch SCTs under dark skies, the cluster resolves itself into a grainy ball. Near M72 is M73, and M73 is one of the oddballs in the Messier catalog. When you hear Messier object, you usually expect a cluster, nebula, or galaxy. But M73 is really just a tiny grouping of 4 stars, forming a Y shape. It's usually described as an asterism, which means it's a pattern of stars that appears close together from our point of view, not necessarily a true physical cluster. So why is it in the Messier catalog? Because Charles Messier was simply making a list of objects that could be mistaken for comets. Most telescopes in the 1780s didn't have the optical quality to distinguish M73 from looking like a comet. Today, we know what it is and enjoy it as a fun stop in Aquarius. Our next target is NGC 7009, the Saturn Nebula. This is one of the better planetary nebulae for small telescopes, and it gets its nickname because in larger scopes, with enough magnification, it can show little extensions that make it look a bit like the planet Saturn with its rings. In my 8-inch Dob at low power, NGC 7009 appears stellar, but it's bright enough to take magnification well, and that's where it becomes interesting. As you increase the magnification, it starts to separate itself from the surrounding stars, and you should see that tiny bluish or greenish disk. Using a nebula filter will help, especially from light-polluted skies. Planetary nebulae are the outer layers of dying stars, and the Saturn Nebula is a great example of how much detail can be packed into something that looks so tiny in the eyepiece. Next up, we're going to M2, and it's the showpiece globular cluster in Aquarius. This is the one that's going to be the most rewarding in this part of the tour. M2 is bright, concentrated, and much easier to see than M72. In binoculars, it shows up as a small, fuzzy spot under decent skies. In my 8-inch Dob at low power, it appears as a bright round glow with a strong central condensation, and some of the halo stars begin to resolve. With larger apertures and higher magnification, the outer edges can resolve into hundreds of stars, but even in a modest telescope, M2 is a satisfying classic globular cluster. If you haven't observed it yet, you've surely seen pictures of our next object, one of the most famous planetary nebulae in the sky, NGC 7293, the Helix Nebula. The Helix is sometimes called the Eye of God, although I just call it the Helix Nebula. It's one of the closest planetary nebulae to the Earth, at roughly 650 light-years away, and in photographs, it's absolutely spectacular. What we're seeing is the outer atmosphere of a dying star, pushed out into space, with the hot central white dwarf lighting up that expanding shell from the inside. In images, the helix looks big, detailed, and obvious. Visually, it's a different story. This one can be tricky. Its light is spread out over a wide area, so it has low surface brightness. That means it can disappear pretty easily, especially in conditions with light pollution, haze, or poor transparency. Dark skies help a lot, and a nebula filter can make a big difference. A UHC filter can help, but an O3 filter is even better if you have one. In binoculars or with a low-power telescope under good skies, look for a large, faint, round glow. Don't use too much magnification at first. This is one of those objects where low power and a wide field are your friends. The challenge is not that it's small, it's that its light is so spread out that your eyes can slide right over it. I've observed this with my 70mm refractor under dark skies. Even at home with my 8-inch Dob, the helix is visible as a ghostly glowing ring in the eyepiece that becomes a bit more distinct with a filter. If you're using a telescope, try sweeping slowly and using averted vision. Look slightly off to the side instead of staring directly at it. You may notice the nebula first as a subtle brightening of the background sky rather than as a sharply defined object. And don't be discouraged if you have trouble finding it. The helix is famous because it's beautiful and nearby, not because it's easy to find. Under the right conditions, though, it is one of the great planetary nebulae in the autumn sky. Finally, let's wrap up our tour with the double star 41 Aquarii. Located in the same general part of the sky as the Helix Nebula, it's a good target for a small telescope. You're looking for two stars, 1/5 and 1/7 magnitude, that are close together. They're only separated by about 5 arcseconds, so once you locate it, you can crank up the magnification. The brighter star shows a warm yellow or orange color, while the fainter companion appears bluish or bluish-white. The colors can be subtle, and different observers may see them a little differently. Use moderate magnification and take your time. Once you separate the pair, look at the differences in brightness and color. That's really the appeal of double stars. I enjoy them because they each offer something unique and beautiful to study in the eyepiece. Well, that's our look at the September 2026 skies. If you try any of these targets, let me know what you see. Leave a comment, send me a message, or share your observations with me through the website. The September Observing Guide will be available at astroguypod.com. It contains a moon phase calendar, planetary data, finder notes, and observing tips for the month. Download it, keep it handy, and use it to plan for a few nights under the September sky. Feel free to email, send a text, or leave a voicemail with questions or suggestion. The contact info is in the show notes. If you enjoyed the episode, please like, subscribe, and share it with someone who loves the night sky. Until next time, may your skies be clear, and as always, Carpe Noctem, seize the night. I'm Wayne Zool, and this was the AstroGuy podcast. Thank you for listening. As always, your questions, comments, and suggestions are welcome. Keep wondering. Keep your eyes on the sky. Have fun. Carpe Noctem. Seize the night.